Welcome once again to explainingcomputers.com and to the first of two videos in which I'm going to build an i7 PC. Specifically, I'm going to be rebuilding the computer I use to render my 3D computer graphics, although as I'm only going to be keeping the case and the power supply, this is in effect an entirely new build. Right, to do this build I bought lots of different PC components and we'll look inside all of these exciting boxes over the course of this video and the next one. But the component I think we should start with is this one. This is our processor. This is a 6th generation Intel Core processor, what's called a Skylake processor, and specifically, as you can see, this is an i7-6700T. And if you're thinking to yourself, where's the fancy box that this processor came in? Give us a look at the box. I can't. This is a T-based processor, and a T processor stands for a tray processor, which means it comes in this little plastic wallet you can see here, and that's all you get. You don't get a box with a T-based processor, you don't get a manual, you don't get a cooler, you don't even get a sticker to stick on the front of your PC saying Intel i7 inside. And the reason for that is that tray-based processors like this one are normally sold in trays. Say, 100 of these in one tray, that must be amazing to see. They're sold to large system manufacturers. But you can get hold of T-based processors from some of the more specialist dealers. I got this one, for example, from quietpc.com. Now, if you're thinking, why have I got the T-based processor? Let's have a look at this table of different Skylake processors. And I'm showing you here all three available i7s at the current time, plus a few i5s and i3 just for good measure. And as you can see, they all have slightly different specifications. This doesn't show you all the specs, but the ones I want to mention here. And if we look at the i7s, I could have bought a 6700K. That's an overclockable processor, but I don't want to overclock this processor, so I haven't bothered about that. I could have bought the standard 6700 or the 6700T. And as you can see, this is the slowest of the three i7s available, and you can see that reflected in both the stock speed, the turbo speed, and in the passmark, the performance score. But the key column here for me is the TDP column. That's the thermal design power column. Now, thermal design power is measured in watts, but it's not a direct measure of the power used by a processor. Rather, it's a measure of the heat generated by the processor when it's running at full load. So if you think of your microprocessor as a small fire, what we're seeing here is the 6700K would produce up to 91 watts of heat, the standard 6700 65 watts, and the 6700T 35 watts of heat. And because I'm going to be fitting this processor in a rendering system where it's going to be running at full processor utilization for virtually all of its life, often 168 hours a week, I want to run the processor as cool as possible and also as power efficiently as possible, because although TDP doesn't fully reflect the power use of a processor, inevitably the T-based processors use a lot less power than the standard i7 processors. They are power optimized chips. So there we are, the processor for this build, our lovely Intel i7-6700T. If we just flick it over, not really things to play with microprocessors, but this is a video, so let's have a little look. You can see the back of the processor. Long time since we've had pins on the back of Intel processor. It's got contact pads there, which will then match up with the pins in the socket on the motherboard. And talking of the motherboard, it's probably now time to have a look at that. Right, having selected a processor, the next thing you need to choose when you're building your own PC is the motherboard. And here, as you can see, I've got a Gigabyte board. I always buy Gigabyte boards, I just happen to like them. And I've got specifically an H170M DS3H. Now, when you're choosing a motherboard, there's a few things to bear in mind. First of all, you must get a board with the right socket type, which here means an LJ1151 for the Intel Skylake processor. And you then more broadly need to choose the chipset. And here I've chosen a board which, as you can probably see in the title of the board, is an H170. It's also written down here in smaller letters just in case we haven't noticed. And the chipset is basically the set of components, the set of chips on a motherboard that control the flow of data between the processor and the memory, the storage devices, the graphics system, etc. And if we bring up this table, I can show you the three most common chipsets you would be using on a consumer-based Skylake PC: Z170, H170 or H110. As you can see here, if you want to overclock your PC, you're going to need a Z110 Z170. If you want to have an M.2 socket, you're going to have at least a Z170 or an H170. I wanted an M.2 port, which meant I couldn't have an H110 chipset. And also, I wanted to make sure I got 4 DIMM slots, 4 memory slots. I'm going to occupy 2 of them. That'll leave me expansion capacity in the future. I wouldn't have had that with an H110 board. And as you can also see, you get fewer SATA ports, and also you also get fewer USB ports. So there's nothing wrong with an H110 chipset. It's a lot cheaper than using an H170, which in turn is cheaper than using a Z170. Right, we've talked about it a bit, but it's important to make sure you know about which chipset you're going to buy. Let's look inside here. I always like motherboards and looking in the boxes. Motherboards are really cool. We've got here some SATA cables, but of course this is the main thing. This is the board itself. Let's get it out. Get that out of my way. There we are. This is our motherboard. This is a micro ATX board, which is perfectly big enough for our purposes here. Crinkly as things so often are in these videos. Let's have a look inside. I think I'll cut this with scissors so I don't damage the bag too much getting in. There we are. And inside here is our lovely motherboard. Take it out nice and careful. There we are. There's our lovely motherboard for this build. We check out what we've got here. Here's the processor socket. Here are 4 DIMM slots to put in memory. Here's our PCIe slot, which you could put in things like graphics card if we wanted to. You could put 2 graphics cards on this if you wanted to, have crossfire graphics if you want. You've also got here the slot for the M.2 SSD if you want to put one of those in. And of course on the back panel we've got a range of sockets, including HDMI, DVI and VGA for connecting a monitor. We've got USB 2 and USB 3 sockets. We've got gigabit Ethernet, audio jacks, and we've even got a legacy port for connecting an old style PS2 keyboard or mouse, which could be useful when installing Windows 7. We've also got a good complement of the usual internal connectors, including this bank of SATA and SATA Express sockets. But now I think it's high time to get on with actually building something, and so I'm going to remove the cover on the processor socket. There we are. And we can then open the socket retaining clip like this and open it up. I can then take our processor and very carefully drop this into the socket, making sure that the triangle matches triangle. It's pretty difficult to get them the wrong way around these days. There we are. And then now if I just put this back, retaining clip goes underneath, that goes under there. We now have our processor fitted in our PC. But of course, if we left the processor just like this, naked as it were, it would burn up very quickly. It would get far too hot. So the next thing we need to think about is fitting a cooler. Right, it's cooler time, and I've got a fantastic cooler for this build, the Noctua NHL9X65, which is actually an enhanced version of a cooler called the Noctua NHL9, which I used in a build a couple of years ago on an i3. Now, this is a low-profile cooler, and it's slightly bigger than the previous NHL9. It's 65mm high, as you might guess from the wording on the box. So this is not a cooler to use if you want to build a PC and overclock it. That's not going to work. But if you want to build a PC in a relatively small case, and I'm using a fairly small case for this, fairly low height case anyway, this is a great cooler to use, particularly if you're using a low TDP processor. Remember, I've got a processor with a TDP, a thermal design power of 35 watts. This can go in theory up to 84 watts of heat dissipation. So this is great for a lot of situations unless you're going to be overclocking. So let's get inside, open the thing up. I think in fact we need to open it the other way because you won't see otherwise. And if it's like other Noctua coolers, it's extremely well packaged, and it looks like it is. There is a box here of parts for mounting the cooler. And then, oh yes, inside we see the cooler itself. There it is, look. And how does this come out? Oh, it's in loads of cardboard there. There we are. And if we get this thing out, I always used to buy coolers from Zalman, but I've been converted in recent years to these things from Noctua. So let's just put that down so you can have a proper look at that. And as you can see, it's a very nice cooler. This is a really nice piece of equipment. They do great quality. You can see on the bottom there, you can see the very, very shiny base plate which will actually fit onto the processor, covered by a piece of plastic. So really, really shiny, but we'll leave the plastic on for now so we don't touch that or any contamination in there. You can see the heat pipes, 2 coming out that side, and I presume 2 coming out the other side, and of course the fan on the top. So this is a lovely piece of kit, and I think we should get on with mounting it on our processor. And to do that, we need to take various mounting hardware out of the box. So let's go back to the box we took out earlier. Just flicks open at the back there, and if it's like other Noctua coolers, which it is, it's very well organised. We've got some manuals and things here. We've got the Intel mounting hardware, which we'll be using in a second, because this is an Intel processor I'm using it with. There's also an AMD set of mounting hardware, which I won't need, but you would use if you're using this on an AMD processor and motherboard. We've got some what are labelled common parts. This is the Noctua thermal compound, which we'll use when we mount the thing on the processor, and also what they call their low noise adapter. Crinkle, crinkle, low noise adapter. That basically means it runs the fan slower, which reduces noise but also reduces cooling. I probably won't use that. And finally in here we've got a special Noctua screwdriver. I don't know why it's that special, but there it is. Nice to have that, I'm sure. And the bit we'll need first of all, which is this, which if I take that off, this is the base plate. This goes under our motherboard and then comes up through, and we mount the cooler on top of that. So the first thing I need to do is to mount this to our motherboard. And so here's the back of the motherboard. This is the opposite side we normally see, but we'll put this in there like that, and then we just flick this over, let it come through. There we are. We can now see the processor, and those things have come through there, which is good. We can then just drop on these little plastic standoffy things. I have great confidence in the Noctua system. It really seems to be very nice. And we now just take these little bars like that. Those drop on there and there. And it's good to see there's great clearance. None of the components are risk of being damaged there. And then we just take these little thumbnail things, screw them on like that. There we are, 2 there and 2 more. I do like the way when you build a PC, you're doing both computery things, electronic-y things, but you're also doing this physical construction. It's a very interesting mix of things go together when you're building a PC. So that's all now well in place. Is that nice and tight? It is. That's really good. And so the cooler will go on top of here. You can see I've taken the fan off the cooler. It makes things a lot easier to mount, and we'll just be able to screw it in on the different sides. But before we do that, the first thing I need to do is to remove from the cooler its plastic cap. So we've got the actual surface there ready to join with the processor. And the next thing we need to do is to apply some thermal compound, some of the Noctua NTH1. So I'll take off a little cap from the thing here. This is a screw, and get the thing off. There we are, it is off there. And we can now apply this to the top of the processor. You need a little bead, about 4 or 5 mil bead, they say, on Noctua. I know there's a lot of debate about this. Should you use P? Should you use spread? Well, Noctua say you should use P, and I think I would trust them given how well they build their systems. So if I now just take the heatsink, this is the moment of truth, isn't it? We can put shiny surface onto the processor, and I can just drop this down carefully on top, lining things up. Our thermal paste will of course spread, or I can feel it sort of going as I speak. Sort of, there we are, just move it around very slightly, just spread the thing out, no air bubbles coming in, just keep the pressure on there. And then all I need to do now is to get onto the screwdriver and start to screw down. Do a bit on one side to start it off, bit on the next side to start it off. Oh yes, that's taking. Once you've started off, you're fine, aren't you? You then just keep going nice and gently. A little bit more on that side. These are beautifully sprung things. This really is going to work very nicely. I think this is going to be a great cooler install. Sometimes you just have a feeling it's going well, don't you? I can't see how that stuff is spreading on top of the processor, but I can sort of imagine it quite nicely. I think that's probably about enough now. We don't need to be absolutely to ends of the earth. That's nice and good and solid. That is, I'm very, very pleased with that. So all I need to do now is to put the fan on. The fan, dear me, has some clips on it, so you can obviously clip it on. That's the reason you have clips, isn't it? And I've lost both the clips. What's going to happen? It's going to end up about there in terms of the wire for the motherboard. So, and the clips drop in, I think, like this. It's far easier to do this if you take the fan clips off and then put them back on again. Although it's not as easy if you keep dropping them like I do. I'm trying to do 12 things at once here. That's not the best piece of advice for how you should run things in your life. But there we are. Put those clips on there. And now if I can hold them in place, keep them down, they will drop on either sides of here. Like that. Goes under there. Oops. Be very careful when you're putting these on. Of that wire, you don't want to damage that little wire, do you? No. And down the other side, let's do that one first. That one's now in. That one's now in. Wire's perfectly happy. We've got our fan mounted on top of our cooler. That's lovely. So all I've got to do now is to tidy this wire up somehow, and then that'll be a tricky thing to tidy up actually. That's not going to go in easily. Let's push it under there like that. It will end up somehow going into the top like that. That's where it plugs in, but I need to get the wiring nice and neat. Not neat. If I don't get my wiring nice and neat, you'll all moan at me. But there we are. We've now got our fan or cooler mounted on our motherboard. Right, having spent some time sorting out the cooling, let's turn to something a bit more straightforward, which is the memory. And here I've got two DDR4 DIMMs, 4 GB each, so this gives me a total of 8 GB of memory. And these are from the Kingston, they're HyperX Fury brand. If I just get into these, I think we can just cut down the edge down here. It shouldn't be too difficult to get into here. Open this thing up like this. It doesn't want to let me in, does it? No. There we are, we're going to get in. We don't care if they want to let us in. Always be very, very careful handling memory because, of course, it is static sensitive, and also it doesn't want to let me in anyway. There we are. Not taking it apart the most effective way there, but let's just quietly put this on the surface for you there. There's our first DIMM and there's our second beneath it. Don't they look lovely together like that? But of course they really want to be in the motherboard, so we'll fit them in there. We'll take the first one, which will be fitting into DDR slot 2. You have to fit in the slots in pairs, and 2 is in the back. If you're wondering why I did 2 first, it's simply because I want you to see what's going on. So I now fit into DIMM slot 1 at the front, and then we'll have both our memory modules fitted. We've now got 8 GB of memory on our motherboard. If I cut to a different angle, you can hopefully also see that the CPU fan, which I fitted in the last segment, which you didn't really see, is now plugged in there. And I've tidied up the wire a bit. I've actually rotated the fan around, so it's all looking nice and neat. So there we are. We've now finished constructing the first part of the computer, the motherboard, fitted with the processor, the cooler, and the memory. Right. Just to test that things are working okay at this stage, I thought I'd do a test boot. So what I've done is to drag out the PC, the render box in which we're going to put this motherboard, opened it up, and I've connected in the power lead, so we've got power to this board. And I've also just connected a couple of jumpers to what will be the power switch on the PC. So if I just try and convince it to turn itself on by doing this, oh, that was successful. It's come to life, the fan has come to life, and there's also some very interesting glowing LED channels down here. I think this is an audio channel you can see down here, but obviously you probably can't see that in the movie lights, but at least we can see the PC has come to life. And if we just look at the monitor, unfortunately I can't record it in my normal fashion, I'm just pointing a camera at it, but you can see the PC is running and it's clearly gone into its BIOS, or whatever we're supposed to call it. These days, certainly Gigabyte still call it a BIOS. And if we just hit the keyboard to get to the status, we can see that, look, all of our CPU cores are working perfectly well. That seems rather good. And we could flick through here and everything seems to be in order. It's obviously a slightly confused computer because it has Absolutely no storage connected at the moment, which clearly will slow it down a little bit, or rather let it do absolutely nothing. But we have proof now we've built a working computer and something we can add things to, including storage and a case, in the next video. An Intel i7 processor really is an amazing piece of technology. Not least, a Skylake i7 contains about 1.75 billion individual transistors. And it's made using a nanolithographic process with a resolution of 14 nanometers, which means that the minimum feature size of a component on the chip is down to about 42 nanometers across, which is only about 300 atoms across. And for me at least, reflecting on that fact brings yet another dimension to doing your own PC build. But now that's it for another video. If you've enjoyed what you've seen here, please press that like button. If you haven't subscribed, please subscribe. And I hope to talk to you again for the second part of this build very soon.